Hello and welcome to today's webinar. The topic of the OWASP API Top 10 is never far from application security's mind, and in response to popular demand, we're running the webinar today. This session provides you with practical examples of how you quickly and easily avoid some of the common mistakes that companies are continually making when deploying their APIs. I believe one of the key takeaways from today's session is that by adopting a proactive approach to your API security, which in reality means implementing secure by design methodologies, your company will be better equipped to handle many of the challenges thrown at your APIs once they're in production. So with that in mind, let me introduce you to today's speaker. Anthony Lonergan heads up our developer relations here at 42Crunch, and in his copious amounts of free time is also the editor behind our very popular APIsecurity.io newsletter. This newsletter is the industry's go-to source for information on the latest API security breaches, with tips and advice on best practices to avoid many of the attacks covered in the news. Before jumping in, I'm going to just share some housekeeping rules for today's session. All of you are muted. However, we do invite you to submit questions via the Q&A function, and we'll answer those at the end of the session. And just in case you're worried, a recording will be shared after the webinar. So if you want to listen to it at your leisure or share it with colleagues, the recording will be available on demand. So over to you, Anthony.
In this webinar, we want to make a connection between adopting secure by design practices for API development and reducing the number of OWASP API vulnerabilities in your API code. So on the agenda, we're going to cover, first of all, what is secure by design, and in particular, why cybersecurity agencies are now pushing companies to follow this approach. We'll take a look at real-world cases of OWASP vulnerabilities, just so we're clear about what problem we're trying to solve with this secure by design approach. We'll look at the design of an API, we'll look at how to leverage Open API to implement secure by design practices that help us prevent vulnerabilities. And then at the end, we'll look at how you can upskill your development team and get started with your own secure by design program. So before we start talking about secure by design, let's first be clear about what are the problems we're trying to solve with this approach. So when it comes to API security, two of the main challenges most teams have is preventing unauthorized access into their systems for people to cause damage, and the other is preventing leaks of your data, especially your customers' data. Now, APIs are top of mind for both of these problems because, well, first of all, APIs are very easy access points into your system. Almost anybody now can pick up, a tool like Postman or Burp Suite and generate an API test and just start hammering your APIs for vulnerabilities. And then you also have, there's so many free courses now on, advertised as teaching about OWASP vulnerabilities, but they're also teaching people how to, hack and penetrate your APIs. So APIs they're a really attractive, target for hackers, and again, they're very easy to access. And then the other point is that APIs are all about the data exchange. So they're very rich in the amount of data that's sent to and from APIs, and they facilitate that access to valuable private data that hackers are often targeting. So again, that's what makes APIs such an attractive target. The problems we're trying to solve are those two of unauthorized access and data exposure. Then we really need to make sure that our APIs that we're deploying into production are hardened and that we're reducing the number of security bugs in those APIs. So that's really the problem that we're trying to solve with secure by design. So what is secure by design, and why should teams consider adopting this for API development? Well, there's a big push, particularly by regulatory agencies, for companies to adopt secure by design. It is central to a lot of these industry frameworks like the Cyber Resilience Act in the EU and the Secure by Design initiative in the United States. This one actually is run by the CISA group, but in collaboration with cybersecurity agencies from many other countries: Norway, Singapore, Denmark, Australia, UK, Canada. So you have all of these cybersecurity agencies, many of whom are overseeing and regulating the software development in critical industries, and they're all promoting secure by design as the most effective way to avoid system breaches and data leaks. Now, the basic concept of secure by design is that your security is built in, it's integral to your development process. So it's not something that you do on top of your development, it's more about how you develop. And it's described often in terms of principles and practices. So the principles are more the why question. So like, why do secure by design, or what do we hope to achieve from this approach? And it's often described in terms of moving the responsibility for security away from the software user and pushing that responsibility back on the software producer to ensure that their software is secure out of the box. Then the practices are more about the how question. So how do we do secure by design, and also who's responsible? And you'll find information about the different practices that are recommended in the documentation, which is geared towards specific vulnerabilities. And you can see here is where we have quite a large overlap between the practices that are recommended for secure by design and also the vulnerability prevention guidelines in the OWASP documentation. So oftentimes when people look at the documentation for OWASP, the focus is on the vulnerability and how to create tests to find or exploit the vulnerability. Now that's quite useful for penetration testers, but for developers, the real focus is on this section, because this describes the best practices for software development in order to prevent the vulnerabilities in the first place. And so that's exactly what we're looking for here, that connection between the practices we follow for secure by design and how they help to prevent these OWASP vulnerabilities. So clearly these cybersecurity regulatory agencies believe that secure by design is the most effective way to produce secure code, reduce the opportunity for unauthorized access and data leaks. But what about the development teams who have tried this approach, this secure by design approach? Well, we have results on that just recently in October from this group Secure Code Warrior, and you can read the report here. Now, this group monitored the progress of teams who were just beginning a secure by design program. They looked at over 600 different companies. They traced the data for over 9 years and across 250,000 developers who were upskilling on secure by design practices. And they were looking at the ability of a team to reduce the number of vulnerabilities in their code as a consequence of upskilling in these secure by design practices. And the results are very promising. So, for example, for large teams with more than 7,000 developers who had been trained in these secure by design practices, the vulnerabilities reduced on average by between 47 and 53%. And then for smaller teams, they saw even higher reduction rates when the training was focused on specific groups of vulnerabilities. So when you had very targeted training. So in general, it seems that this secure by design practice is a good approach for security. But then what about specifically API security and the ability to reduce the number of API vulnerabilities in our code? So let's look at some real-world cases of API incidents, and we can consider whether or not secure by design would have helped us to prevent those particular incidents. So at 42Crunch, we have a bi-weekly newsletter called APIsecurity.io, where we review all of the latest API incidents that happen in industry. We look at what the root cause was, and then we try to recommend best practices for other teams to avoid those vulnerabilities. By the way, if you haven't already, do please sign up for the newsletter. Now, in preparing for each issue of the newsletter, we review hundreds of news articles, reports, security advisories, and we're looking specifically for API vulnerabilities and breaches. So it gives us a bit of a perspective on what are the most common OWASP vulnerabilities that teams encounter. So this is the list of some of the different types of OWASP vulnerabilities. And then for each of these different vulnerability types, these are the incidents that we've covered in the newsletter just over the last few months. So the way we select which incidents to cover in the newsletter is we look for cases where there's enough information about the root cause of the problem so that we can dig in and understand what was the likely mistake made during the design or the implementation, the coding of the API that caused the vulnerability, or at least what part of the API was vulnerable. And there's a good mix here of different teams that had different problems. So you have small independent teams who are working on open source code. You have mid-size enterprise teams who would have various resources and expertise on the API security. And then you have the big players like Microsoft, Cisco, IBM. Some of these are technology vendors who themselves specialize in API or application security. So all of these have very similar API security issues. All right, so let's take one of these incidents as an example, and then we'll try to apply this idea of secure by design to see if it would have helped to prevent the incident. So this is a relatively recent case. So Granicus, this is an e-filing system. It's used by some of the courts in the United States to allow people to upload documents. Now, this platform had an API vulnerability in the registration part of the platform. So we look at the drop-down menu over here. So it allows me to register as a particular organization, and it gives me these options in this drop-down menu for the type of organization I can register as. So importantly, you can see there's a limited set of options I can choose from. So let's see what happens here then. So what happens is when somebody is registering on the web page, once they select the organization type from that drop-down menu and they click on the registration button, the page sends an API request to the Granicus API to register the organization. And it sends along a type code that corresponds to whatever business type I've selected from that drop-down menu. And then the API uses that to register or create a new organization, I guess, on the database. Now, the problem here was that it looks like the API doesn't check to make sure that the type code value it received matched any of these four values that's available on the front end, on the client side. So it looks like the API developer probably assumed that the client takes care of that because it only presents those four options to users. And so the API simply accepts whatever value it receives from the client and creates an organization with that type code. Now, the problem with this is that a hacker doesn't need to use your web form to interact with your API. It's trivial for most hackers to gain direct access to your API, whether your APIs are used on a web page or in a mobile app. And then they can simply use something like curl to send that API request directly to your API. Now, in that case, I can send whatever value I like for that type code, that organization type. I'm no longer limited to the values that you've presented on your web page or in your mobile app. And so this allows a hacker to try out all different types of values. And in this case, it allowed the hacker to register an organization with elevated privileges. So essentially, it made them an administrator of the platform, and they could potentially access the private legal documents of other users. But the key point is that the vulnerability or the exploit was in the data exchange between the client and the server. And I can tell you, having reviewed all of these incidents, I think almost every single one of them was also either vulnerable or exploited in the data that was sent to and from the API. And that's often the case because all of these APIs often have very similar characteristics. So, for example, it's popular to use the term REST API, but in fact, a lot of the characteristics that we associate with REST APIs, so things like the paths and the verbs and operations, query parameters, headers, those all come from the HTTP protocol. So our APIs are leveraging the HTTP protocol to standardize how data is sent to and from our APIs. Where it gets tricky with the APIs is the data, the business data that's passed to and from the API. because that's your business data. That's the data that's passed as part of your business application, whether you're in finance or healthcare or telecommunications. Your APIs will handle different data. And there's no universal rules or constraints on what that data could be or should be, or how to distinguish, valid data from potentially malicious data. So you sort of have to add those rules yourself. You have to apply those rules yourself to constrain the data that your API will accept or return. And one of the most common ways to define those rules is using OpenAPI. Because using OpenAPI, I can define all of the structures for my HTTP input and response data, but also all of the content and the values that make sense for my API. So it's a very strategic type of data validation, and this is our secure by design practice for our APIs. So here we have an OpenAPI definition for an API. It has a registration endpoint, very similar to our Granicus example. Here's my list of the properties that are supported for the API. So this is my whitelist. These are the only properties that my API will accept. So we also define the acceptable property values that make sense for our API. So here I have an account type property. It's very similar to the typecode property for the Granicus case. And so you might imagine if I had a mobile app or I had a web page for this API, I would have had a drop-down menu which would have presented these as the only two options for a user to set for the account type. Now the difference with our design here is that we're also enforcing those options or constraining those options to only those two values, which means my API will only accept those values. Any other values it's going to reject. Okay, so this is my whitelisting. This is my secure practice. Now let's say I'm a developer and I'm not aware of that security practice, or let's say I forget it. Well, what I can do is use the API security audit service, which will basically give me a reminder about the security practices for designing my API. So here we see it's now found a problem, and it's telling me that I need to include a pattern to define constraints for this account type property. Okay, so it's picking up that I haven't followed the security practice of whitelisting for this property. So let's go ahead and add that back in. So now we have a more secure design. So this means we have a secure design, but what about the API code? I also need to make sure as a developer that I add this security practice into my API code. Now, maybe as a developer I forgot to add it in my code. Maybe somebody made a change, caused a regression, so that security practice is no longer implemented. So for that we have API scan. So just as API audit helps to remind us of security practices in our API design, we can use API scan to remind us of practices in our API code. So API scan performs contract testing. It's going to verify if my API code matches my secure API design. So now API scan is running suites of tests against my API to see does it match the secure design. So looking at the API scan results, it's found a number of cases where the API code does not match the API design. If we drill down to that specific case of the account type property, again, we see that when it used an invalid account type, the API code is still creating those accounts. So the exact same situation that we had for that Granicus case. So API scan is helping to remind the developer that they haven't implemented the correct security practice in their code, even though it's in your design. So by adopting that security practice of whitelisting our API input, it would have prevented the OWASP incident at Granicus. So that's great. That's exactly what we're looking for, that connection between following a security practice and preventing OWASP vulnerabilities. So what other issues in this list could we also prevent with a similar approach? So let's go back to our OpenAPI file. Let's run the API security audit and see if it can remind us of any other missed security practices. So let's look here, for example. It's reminding us that, okay, all of our APIs should accept HTTPS. So obviously, if we're exposing our API over HTTP, that is a bad security practice. So let's improve our design. And that ensures that all of our APIs use HTTPS. And we'll again implement that in the code and test to verify with API scan. Now, that API decision to make sure that all of our APIs use HTTPS, that would have removed the vulnerability at fleet management, where they had exposed APIs over an insecure HTTP connection, and it exposed a fleet of vehicles to man-in-the-middle attacks. So again, a design decision that helps to prevent a real-world vulnerability. Here's another issue. So in this case, it's reminding us that we should enforce credentials or authorization tokens for our API endpoints. So again, in this case, it's a useful reminder that I need to add that. So by following that design practice and designing our APIs for the proper authorization, we would have prevented all of those broken authorization issues at WhatsApp, Siemens. Many of those were for mobile apps where the API failed to enforce the required credentials, and so the mobile apps were hacked. So again, I can whitelist this property to make sure that only valid IBAN values are accepted by the API. And so again, making that design decision and enforcing or validating all JSON properties, we would have prevented all of those security incidents. So that was SSRF, SQL injection, patch reversal, JSON injection. So all of those issues were caused by a lack of input validation on JSON properties. And again, it goes back to a point we made earlier that oftentimes many vulnerabilities are caused by a small subset of root causes. And that's certainly the case for API vulnerabilities. So remember, as we're going through this design example, we're not specifically designing our API to avoid all of the vulnerabilities that these businesses experienced. In fact, we're not even designing the API to avoid all of these different types of OWASP vulnerabilities. I just need to design and implement my API to do exactly what it's supposed to do and exactly nothing else. But in doing that, we make our APIs inherently secure or secure by design. So let's continue with this and see what else we can find. And just as we did for the JSON properties, we should also do the same for our input parameters. We're going to whitelist that input and make sure that only valid values come in for those expected data types. And again, just as we've done with other parts of the API design, if we validate and whitelist the input parameters, it would prevent the issues such as at IBM, SolarWinds. Again, there's mostly SQL injection, patch reversal. And so using this approach, we can work our way through the structure of the API request and response using whitelisting to validate the data, and in so doing, we'll help to prevent these types of OWASP vulnerabilities. So just as we saw with input parameters, we performed the same type of validation on input headers, would have solved those issues. For access control, a developer can distinguish between privileged access for APIs, so they can define, for example, which API endpoints or services should only be accessible to administrators. So again, you implement that practice in your design, you verify it in your API code. That would have prevented those issues at Kia, Microsoft, and Cisco. And just as we did for the input parameters, you also can validate or whitelist the response properties to ensure that the API only returns the expected data and doesn't leak private or customer data. That design decision would have prevented all of those issues of excessive data exposure at Apple, Spoutable, etc. And then finally, just as we did for the response properties, you should also validate and whitelist the error response to make sure you're not leaking data or stack trace information in any error response, which is exactly what happened at Cox Communications and Life 360. And so by following these secure by design practices, we could have prevented all of these incidents of OWASP API vulnerabilities. Okay, so finally, just to come back to that study that we looked at earlier, where you had 600 different companies who are following these secure by design programs. Two other points that were highlighted in the conclusion to that study. The first is that the most important and impactful step you can make in a secure by design program is to invest in improving the skills and the tools of your API developers. So providing the training to make sure developers understand the merits of secure by design and the tools to help them integrate the practices into their day-to-day development work. And then the other point that emerged from the study is that in order for a secure by design program to be successful, it requires top-down support and leadership. So executives and management need to make sure that security is an essential part of product development. Otherwise, developers lose interest and don't continue the practices over time. So in terms of the tools then, API Audit and API Scan, these are the two tools that I was using in the demonstration today. So API Audit gives the reminders about the right security practices for your API design, and then API Scan gives the reminders of where you've forgotten to put those or implement those practices in your API code. So both of these tools are available in developers' IDEs, which makes it easier for developers to use them on a day-to-day basis. And then the test results that you get from both of these tools are both an indication of the adoption of your secured by design practices and also on the effectiveness of those practices for reducing vulnerabilities in your code. And both of these tools can be integrated into a CI/CD system so that you can automate the running of both the API Audit and the API Scan. And that ensures that your entire team meets a minimum threshold for your security design. And then finally, from the 42Crunch platform, you can monitor the progress of your secure by design program. You can monitor adoption rates, you can understand your API inventory and the security levels of each API, and you can monitor for specific categories of vulnerabilities that your API team may need more targeted training on.
Thanks, Anthony. So as a reminder, please use the Q&A function to submit questions, and we'll do our best to get answers to all of them. If you're interested in following up on some more information, I'd point you to a few resources. On the 42crunch.com website, we ran a webinar earlier this year with Philippe Derek and Isabelle Moni, which covered a lot of the OWASP API Top 10 from 2023. So if you're interested in doing some further research on the topic, I'd recommend you jump over and have a look at that as well at that URL. And some additional learning for you. So I mentioned earlier our API security newsletter. You can head on over to that URL and subscribe. It's a bi-weekly newsletter which goes out to the industry, covering many of the best practices, tips and tricks on what you need to do to protect your APIs. Anthony is also very actively running our developer community at that URL. Again, you can join the conversation there. And finally, our free tools, Open API Editor, API Audit, and API Scan are available for access at that URL. There you can sign up for freemium usage. And then if you want to get further usage of the tools, you can pay for a single user or team subscription on a monthly or annual basis. Now it's time for some Q&A. Quite a few questions already submitted. So as a reminder, please use the Q&A function to submit questions. First up is a question, Anthony, is API Scan available for all authentication types, including OAuth 2 flows?
Yeah, absolutely. Actually, let me quickly share my screen. Yeah, so I'm back in the Open API Editor. So this is the tool that I was using earlier to go through some of those vulnerabilities. This is a free tool that installs in developers' IDEs, and it just makes it really easy if you have a very large Open API file and you're trying to navigate through the file. This is a really useful tool. So when it comes to the authentication schemes, then you go down to the bottom here and just right click. You can see all the various authentication schemes that are supported. So basically the tool API audit, API scan, they support whatever authentication tools are supported by the Open API standard.
Cool. Thanks, Anthony. Next question. Can we test for BOLA or BFLA? So again, those are amongst the top of the OWASP API top 10 challenges.
Yeah. So in the list of vulnerabilities we looked at, I think there was three cases of BIFLA that we covered. One was Kia Motors, one was Microsoft, and I think the other one was Cisco. Um, and that's basically where you have people who have low privileges, we'll say, on the API, but are able to gain escalated privileges or privileged access to an API. So yeah, we can test for that. So here's an example where you have an API that requires an elevated privilege, an admin OAuth token, basically, to access the service. So if we're running scan on this API, we can add a BIFLA or a BOLA test. And let's say for BIFLA, what you can do basically is say, this is the authentication type that's allowed access. So this might be an admin that's allowed access to this API. And why don't you go ahead and test it against this regular user access, we'll say. So as part of scan running and exercising your API, it's going to check for this authorization to make sure, again, that your API has followed the proper authorization practice to authorize at the service level to make sure you have the right privilege in order to access the API. And then likewise for BOLA, which is where you're making sure that the correct authorization is performed on a resource level, meaning user A can't access the resource of user B. So again, I think that's number one in the OWASP list. It's one of the most common issues you'll find in API vulnerabilities. So yeah, you can absolutely test for that as well using API scan.
Great. Thanks, Anthony. And thanks for correcting me there on the pronunciation of that acronym. Um, and just to remind you folks, this is a view into the tooling which you can download for free from our website and, get to play with and decide if you really want to go for a subscription option with a singular Teams user license. So again, after the webinar, we'd invite you to go and check it out at 42crunch.com. Okay. If we've no design for an already implemented API, how can we get started with Secure by Design?
Yeah, so we have a lot of users who are in that situation. They have both, they're doing design first, whereby they're creating their open API files and then using that as a basis to design their APIs. But we also have people who have, we'll say, legacy APIs and don't have the API documentation. For that, let me quickly open up another tool here. So we have, we can help with that. We have another tool called API Capture. And with that, we can do things like based on if you have a Postman collection, for example, which most people will have, or if you have API traffic or API log files, we can take all of those samples and use those to generate an open API for you. So here's an example. So you gather up basically all these different samples from your API, and then this tool will actually generate the documentation for you. So yeah, for sure. Even if you're just starting with this design approach, we can definitely help you get up and running with this documentation very quickly.
Very cool. Thanks, Anthony. And there's another question here. You mentioned using OpenAPI spec to define all the structures to help constrain the data. How do I ensure consistency across my development team to make sure they're using the same definitions and formats?
Yeah, so let me go back into an example here. One of the examples we looked at earlier, I think, was IBAN. Yeah, so this is a good example. So earlier when we were looking at one of the vulnerabilities, I added in a very precise definition for an IBAN number. Now, I didn't know that off by heart, but where I got that from, I removed this one as an example. So you can see that the tool prompts me. It reminds me, hey, you don't have a pattern for this. And it offers me a quick fix option. And it's allowing me to pull in the patterns from a data dictionary, which is sort of a central repository where somebody in the team who's very familiar with all the different patterns that you use for your business applications, what sort of data you're processing, you can create and predefine those patterns and then use the tool to pull them in. And it just means that all of your developers, whether they're senior guys with a lot of experience or you have junior members who are not very familiar with this, they're all following the same standards in terms of those data formats and patterns. So that is really key, that consistency, that across your APIs, your API ecosystem, that you are consistent with how you're enforcing those best practices. It's a good question.
Great. Okay. Thanks very much, Anthony. And folks, we'll cap it there. We've run out of time today. As I said, a copy of the webinar will be shared with you shortly. And I'd just like to thank Anthony for a very enlightening session. I hope you found it so as well. And we look forward to seeing you all online very soon. Thanks, Anthony.
Thank you.
Okay. Goodbye.